Okay, this is the first of two videos for today's notes, and in today's notes we're going to be talking about mid-segments and trapezoids. Okay, so first, before we get going, we want to talk about maybe like the midpoint. If you recall from earlier in our geometry class, we talked a lot about midpoints in first semester, and the midpoint just meant that, hey, you know what? If I got point A and I've got point B and I connect those with like a line segment, that the midpoint would be exactly halfway in between. That also means that these two segments here I can consider to be equal. I can put a tick mark in, right? So let's keep that in mind. We're going to use that idea as we go into mid-segments and trapezoids. Also, before we get going, we probably want to be able to find the average of two numbers. This is going to be a helpful thing for us to be able to do in a little bit. So if I wanted to find the average of these 1, 2, 3, 4, 5, 6 values, all I have to do is add them up and divide by 6, right? So keep that in mind. Two things. Midpoint means halfway between 2 points. It cuts the line segment connecting those outer points into two equal segments. And to find an average, I add up and I divide by the number of values that I'm adding together, right? Okay, so first things first. What does it mean to be a mid-segment? Well, a mid-segment is this red line here, and within a trapezoid or within a triangle, I'm saying that it's a line, that's a line segment, line, that's parallel to either the bases of the trapezoid, so it's going, here's my two parallel lines, my pair of parallel lines, and it'd be the red line here, or within a triangle, maybe it's just parallel to the base, okay? In other words, if I drew another line up here that wasn't part of the triangle, but maybe it's parallel to the bottom one here, if that makes sense, So it's parallel to those bases, and here's the idea, that this point and this point are the midpoints of each of the legs, okay? So it's halfway up the left line and halfway up the right line, and that is called the mid-segment. So the red line is what we're referring to right here, or in a triangle it might be here, okay? Now, we're going to use this idea because it turns out there's some very easy math that's involved to find dimensions of these trapezoids, for instance. And all it is this. To find the length of this red line right here, all I have to do is take the average length of the two bases. So if I have a length of 8 for the little base and a length of 20 for the longer base, if I take 20 and I have 8 and I add them together and divide by 2, that's 28 divided by 2, that's 14. You know what I know? That JK would be 14 units long. You might also notice that if I take 14 and I subtract 6, I get to 8. If I take 14 and I add 6, I get to 20, right? So there's another way later on that might be able to help us out if we want to look at it this way. Let me zoom in a little bit. It's probably a little bit hard to see, right? So, how do we find the length? Well, we know that the mid-segment is the average of the bases, right? Okay, so let's go through and let's do some example problems. Let's find the length of each mid-segment. So in this case, I'm talking, here are the parallel lines, right? And if it helps you, don't feel afraid to rotate the paper and make it look like this, okay? Rotating your paper is never a bad idea. But you can see I'm trying to find what is the length of AZ here. Well, if I know that the two bases are 11.9 and 7.1 in length, then all I have to do is take 11.9 and 7.1, add them up, and divide by 2, and that should give me the length of the mid-segment. That would be 9.5 units. Okay? That's the length of this line right here. Let's go over here, another example on the right. If I have 3 and 4.2 as the two bases, I add them up and I divide by 2. To find the average length, 3 plus 4.2 is 7.2, so halfway between that would be 3.6. Once again, you'll notice that on each of these examples, that's 3.6. That means that I'm subtracting 0.6 to get to that one. I'm adding 0.6 to get to this one. So I should know whether I've got the correct answer or not because it's literally halfway between the two outer values, right? Okay, let's work a couple tougher ones. Let's find the length of the missing base, right? Just a little bit of a twist on the problem we just did. Here's two approaches to do it. Here's one that's pretty easy. You notice that 31 to 38 means that I went up 7. well, that means that I'm going to have to go down 7 in order to get to the other one, right? So if I take 31 and I subtract 7, that gives me a length of 24. There's one approach in order to get it, okay? Here's another approach which may help us with some more difficult problems, especially if we start getting things like x's involved, where we're not able to just quickly and easily say, oh, plus 7, right? We could say then, if I call this x up here, so I'm doing a different approach here. I'm going to rework the problem. I'm going to get 24 for the answer, but it's a different style, a different method to get to that answer, okay? I know that if I average the outer sides, that I should get the middle, right? If I average the two bases. So if I average x and 38 together, which I can do by adding them up and dividing by 2, the average better be the midsegment, which is 31. Now, I take 2 times both sides to get rid of the fractions. That goes away. So x plus 38 is equal to 31 times 2, which is 62. And if I subtract 38 from both sides, then I would get that x is equal to, no surprise, 24. Okay? So there's a different method to do it. Let's do it on this one here. Okay? Find the length of this missing base. Well, I could just say, listen, how much am I going up to get to 25? I'm going to go down by that amount. Or let's just do it the other way. Okay? Let's say that this is x. If I average x and 25 together, the bases, so if I add x and 25 up and divide by 2, I better get a 16.5. All right, to get rid of the 2, we need to multiply both sides by 2, make them twice as big. So I get x plus 25 on the left, 16.5 times 2 is 33 on the right. I subtract the 25 off, I find that x is equal to 8 units. Okay? I could check it quickly and easily by finding out if I took 25 minus 16.5, that's up 8.5 units. So if I go down 8.5 units, notice 16.5 minus 8.5 gives me the 8, right? So it all makes sense. It all works out. A little bit more math. Got a couple more examples and we're done with this video. All right, see, here's one where it wouldn't be quite so easy, right? You can't just go with the plus or minus thing. But here's what I know. If I average 9x minus 2 with x plus 24, I better get 36, right? How do I find the average? I add 2 values up, and I divide by 2. So if I take x plus 24 plus 9x minus 2, add those up and divide by 2, I better get a 36. So this is where it's helpful in order to know how to do this, like how do I get rid of the 2 here? Well, working through those examples we just did a second ago, we know that first things first, we need to multiply both sides by 2, double it. I also might notice that on top here, if I wanted to combine like terms on the top of the fraction, I have 10 x's plus 24 minus 2, that's plus 22, right? So I can go ahead and say, you know what? Okay, there. I have 10x plus 22 on the left. On the right-hand side, remember the 2's went away. On the right-hand side, I have 36 times 2, which is 72. Subtract the 22. 10x is equal to 50. Divide by 10. X is equal to 5. There we go. We could check it easily by doing this. 5 plus 24 would be 29. 9 times 5 is 45. Minus 2 is 43. Do we go up and down by the same amount? 36 plus 7 gives me 43. 36 minus 7 gives me 29. Hey, it all checks out, doesn't it? One more example off the EOC, and then I'm done with this video, and we'll start talking about trapezoids, or excuse me, triangles. What is the length of midsegment MN? And this is typical to what you'll see on the end of course exam. Okay. Well, in order to do this problem, I would have to know a few things, like what are the lengths of the bases? Because if I can average this value with this value, I can find the length of MN, right? Well, if I look at the bottom, this is 0, 0, and this is 15, 0. That means that I had 15 units in length. The top goes from an x-coordinate of 5 to an x-coordinate of 10. Well, that means it must be 5 units. Well, what's the average of 5 and 15? 5 plus 15 is 20. 20 divided by 2 is 10. Minus 5, right? And plus 5. So I know that it checks out. The answer is 10. All right, if that makes sense, then you're ready to go on to the next video, which is about doing the same thing, except we're going to take these two lines here and we're going to make them go all the way to a point. We're going to form a triangle instead of a trapezoid.